Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. The New Stack thanks Mesosphere for sponsoring this podcast from Kubecon CloudNativeCon in Copenhagen, Denmark. Learn more about Mesosphere and how it unifies public and private clouds into a single pool of resources at mesosphere.com. Just quiet it down a little bit. It's going to be a little loud here because they're breaking down the conference. We're live here from Kubecon CloudNativeCon in Copenhagen, and we're completing our day with a discussion about, I really consider it a discussion about machine learning overall, but I think one of the things I find really interesting right now is the intersection of machine learning with Kubernetes, and we've been waiting for this really to occur, to see when it might occur, and I know Job has a lot of questions, so maybe I'll just turn it over to you for a minute to get started.
Oh, sure.
And before I do that, I probably should introduce everyone. Yeah. So why don't we just, Hugo, why don't you start?
Sure. I'm Jörg. I'm technical lead for community projects at Mesosphere. That means I deal a lot with KubeFlow, TensorFlow, and all other surrounding parties, like, for example, Apache Flink, Spark, and other tools.
I'm David Aronchick. I'm a former product manager on Kubernetes, and now I'm currently the product manager at Google for KubeFlow and the co-founder of the project.
Chris Gaughan. I'm product marketing at Mesosphere, and this is my third EU KubeCon.
Nice. And I'm Job Jackson, managing editor of the New Stack. I'll be helping Alex moderate this panel. No, we got a panel. I'm very curious. Like, data science kind of grew up on its own in most enterprises, and I guess one of the questions that we're just starting to see is you got data scientists that are developing models, they're throwing it over. How do you incorporate that with the mainstream, the corporate IT, the organizational IT departments, and how do you build a pipeline? I keep hearing the word bespoke quite a bit. You got these almost shadow IT projects happening on the data science side. How do you integrate it into the IT, overall IT, and how do you make a loop back so the data scientists are in the loop of the overall product design or whatever it is you're using AI and ML for? So I guess my first question is, what is the current state of machine learning in corporate America or an enterprise or the enterprise globally? How does it look?
Yeah, it's one of the top CIO initiatives according to several analyst firms. Every CIO is interested in doing artificial intelligence, and then every person in IT is interested in doing deep learning. And then every statistician is interested in doing statistics. So the deep learning pipeline, you have the data and you need streaming. Then you need some frameworks like TensorFlow and so on and so forth. And you need somewhere to host it, like Kubernetes. And then you need some way for the user to easily get the data and analyze it, like a Jupyter Notebook. And then you have to build your model, and then you have to have model serving. So I don't know how much we talked about KubeFlow on the New Stack podcast, but we have the PM here, so he could probably do a good job of introducing it.
Thank you. I think that's exactly right. And to extend on Chris's point, you already do have these tools. They're already out there. They're as far away as a pip install or a tarball download. But more than anything, you've had people, data scientists, being asked to create the entire stack. You mentioned bespoke already. They've had to go through and do every single one of those steps on their own. Our purpose with KubeFlow is to give people separations and very easy ways to do this. So all those common components are containerized, packaged, ready to go, and you're able to deploy it. But we don't try and rewrite all those other layers of the stack. we use Kubernetes to deploy that application, and then Kubernetes sits on top of Mesos or any other framework as a way to run it. And so what that means is you can have Mesos experts taking care of what Mesos experts do well, you can have apps people focusing on Kubernetes and making sure that runs well, and then data scientists stay at that top level. But those clean layers are going to greatly accelerate things over time.
Yeah, and just to give a sense how easy it is to get KubeFlow up and running, I'm just a marketing guy, and all I had to do is get a sense of what KSonnet was, and then I got it running on a Kubernetes cluster in maybe 30 minutes.
Wow, that's amazing.
So this is the IT department would use KubeFlow to give the data scientists and statisticians an easy way to access the tools that they're used to using.
Yeah, absolutely. I mean, it may even go further than that. My dream is today a lot of data scientists might do pip install, foo or pip install bar. Nothing against Python packaging. Love it. Love Python. But to be clear, there's a lot that goes in that may not be approved by an IT department or a particular organization. What we would love is using the native tools in KubeFlow, package up things that are appropriate for your particular environment and make those available to data scientists, and then data scientists simply say, I want 1, 2, 3, they can install it themselves, and off they go. But everything under the hood is taken care of by the people who are experts there, like the folks using Mesos. They can say, oh, you know what, you're doing data science and this is business critical, let's get you 100 GPUs. Bam. Mesos can simply do that and be off to the races.
It also sounds like it would ease the process of moving models into production.
Yeah, absolutely. One of the biggest challenges that people have today is that portability of workloads. Having it work on your laptop, having it work on your training deployment, your on-prem cluster, and then your production cloud. By using common tooling and systems that understand these multi-cloud deployments, but still give you a great level of abstraction, things like Mesos, things like Kubernetes, and then things like KubeFlow, data scientists don't have to worry about that. They can just say, oh, you know what, I'm ready to use a Cafe model, or I'm ready to use TensorFlow, or I'm ready to use Jupyter Hub, tick, 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 off they go, and then they can check that entire config into code and share that with their colleagues.
Nice, nice. And as of today, or as of recording, the 0.1 version of KubeFlow has just been released. And it comes, I guess the package comes with TensorFlow and a couple other widely used.
Yeah, just a small augmentation of what you're saying. Mm-hmm. It actually, what we're saying is that every one of the core packages for KubeFlow are now available. So realistically, it only comes with Jupyter in the box and nothing else. You select via 1 through 8 commands the packages that you want, and so you say, oh, you know what? I'd like to add a TensorFlow serving, or I'd like to add Seldon Core. I'd like to use Pachyderm for data processing, or something like that. And one thing additionally that you said that I just wanted to touch on, most enterprises today are already solving some or all of these problems today. They may be getting petabytes of logs every day, processing them maybe on a separate Mesos cluster. Everything that you need for data science that you may already use may not even need to run inside of KubeFlow. It is perfectly okay to say, hey, actually, I got my data processing pipeline all taken care of. Instead of KubeFlow looking inside that same Kubernetes cluster, I'm going to attach to this Mesos cluster over here, pick up that data that's being output, and use it in that KubeFlow deployment.
Nice, nice. Now, Chris and Jörg, you guys had talked today about I guess the whole pipeline, the whole data science pipeline. What were some of the takeaways, and how could KubeFlow fit into that?
Yeah, so every time I've seen a KubeFlow demo, we got TensorFlow up and running on Kubernetes, and then we typically used data that was already set up by on the public cloud provider. So we wanted to show end-to-end, like the open source tools that you would use in order to process the data, to get it into TensorFlow, and to do the model serving. So Jörg he's an big data expert, so he could talk about it a lot better than I can.
So actually, this is pretty much exactly the point you just made. Like this flexibility I get by running it on Kubernetes allows me to run it in many different environments. And kind of what we wanted to show is like, how does it fit in different environments? Like, how can I do data pre-processing, which is like important, like cleaning it, because these demo sets you saw earlier, they're like pre-cleaned and easy to use, but in production I'm very rarely that lucky, so I have to do some cleansing. So how do I do that if I'm on Google Cloud? How do I do that if I'm on-prem? And this is exactly this point, like as we're having those layers, we're having a lot of flexibility of how can we tie it into different stacks. So kind of one key takeaway should have been like, KubeFlow is like one part of this stack, and there are other parts, like data cleansing, where some people use Spark. Later on when serving, how do I get in my request? Like I've seen people coming up with a Kafka queue, just throwing in all the requests. So how do I build all this around? And then of course also like what different storage options do I have? If I'm on Google, it's really great to use cloud storage, but if I'm on-prem or if I have to switch, something like HDFS might be more appropriate. And it's really just about I have different options, and in different environments, different options might be most suitable.
Yeah, I just wanted to add on that. I mean, that's exactly right. And what you generally see, you're almost always going to see in any major enterprise these kind of data processing pipelines. There's no question about that. And over and over and over again, we see these unique environments being set up. And the problem is that there's so many options today. Every data scientist might have a slightly different one. That's perfectly okay. We don't want to dictate exactly what you should use. What we want to do is have a framework and a packaging system that lets you choose what makes sense for your business, and then add it all in. But exactly right. Like you should expect. We would never expect 100% of your pipeline to exist inside KubeFlow. We would always expect it to connect to the other systems and tooling that you have externally to it.
Nice, nice. And it also sounds like it completes the feedback loop. I would imagine once models go into production, you're going to get results from those, and that might the new data could be used to alter the model itself, but that has to go back to the data scientist. And by the fact that they're on the same platform, it makes it easy to do that.
Yeah, that's exactly right. You've really touched on something incredibly important, which is models don't just get thrown over the wall. They are living things. They're just like code. You want to make sure they are constantly staying in track. You want to check their statistics. You don't want to see something veer off because there's a spike in the network or a particular set of users suddenly logged onto your website and now the recommendations are all off. You want to be constantly checking those and having that feedback into the same data and the data pipelines that we were talking about earlier. So yeah, absolutely. You want to continually train on that and continually observe. But that's why it's also so important to think about this as a complete end-to-end pipeline, where every single step is being thought about for machine learning scientists. Whether or not they all exist inside KubeFlow, we're going to try and make a lot of them or all of them available in KubeFlow, but we're not expecting that.
So tell me about the teams that you're seeing emerge that are implementing. Implementing kind of the data science with the corporate with the corporate IT departments, and how are those teams developing? What are you seeing out there?
Yeah, so sometimes corporate IT, they're just in over their head. They get a project that says we need to do deep learning, but they don't know how to do it. They're not experts on this. And then on the data science front, sometimes they want to just use TensorFlow, and they don't know any of the other stuff that they need in order to get it up and running. They're not infrastructure experts. So that's one trend. And then the other trend is you typically want to run your model at scale. You want to run in a distributed system. You want to run it on something like a Kubernetes, but they might not be experts on that and getting up and running, and that's where KubeFlow makes it very easy. And then the third thing is that oftentimes in the corporate IT environment, when they're doing it at scale and they're going to Google and they're getting like this huge amount of like processing power, oftentimes we even talked to a customer today or yesterday where they need to delete the data right after it's analyzed, and they build the model because they're not allowed to have customer data exist for that BU or for that analysis in perpetual state because of data governance laws. They could keep it in public cloud, they could keep it, but it has to be stored in a very specific space.
Yeah, I just to add on to exactly what he was just saying, if you had the chance to see Alexis Richardson's keynote, he had this wonderful example about this this book called The Toaster Project, where a guy tried to, without sourcing a single thing, build a toaster and have it, he attempted to do it and it ended up melting almost instantly. And I think, in a lot of ways, that's what we're doing wrong in computers, in technology today so much. Like, to go in and ask a nurse who's making a healthcare decision to understand the aspects of statistics and material science and all these various things is madness. We would never do that for a second. Yet we ask our data scientists to understand, IT operations and driver installs, and we ask our machine learning experts to, understand, what version of an OS you're running on. That's crazy. Developing these clean layers enables exactly the kind of teams that Chris was just talking about, because now each team can focus on what they're looking for, and that's why cloud native ML is so important. Building those loosely coupled components such that a single team can focus on the things that they do great.
Actually, what does KubeFlow look like to the package provider? If I got a home-built app, or even if I'm managing Jupyter, is there something special I have to do to prepare my software to be available in KubeFlow?
Basically, as long as your software runs inside a container or runs on Kubernetes, you should be good to go. There's a small amount of metadata you'll need to add, and then we actually, as part of the KubeFlow project, require, or strongly encourage anyway, that as you check in your package, you also check in your nightly tests. That's extremely important for us, so that you can say when you use this version, it runs great. But basically, that's it. It should be quite small.
And
sorry. And as an example, during our session, if I could do a plug that we did yesterday, we go through like the end-to-end process. Like, you are a data scientist, you have your data somewhere. How do I then get it into KubeFlow? How do I, set up the streaming in order to get it done? And then how do I do the model serving after I get my model? We go end to end. So we want to fill out that process as much as possible. And so please check out the talk and the PowerPoint.
So actually already, as of right now, I looked at those implementations because I was actually thinking about implementing something there, and as you said, it's really, really simple. So, and I guess there are also more and more different plugins emerging, and this is a really cool trend because, as we discussed, like, different teams have different needs, and the data scientist who's interfacing with KubeFlow, he doesn't have to care about it. It's just being plugged in by whoever controls that layer.
Nice. Now, I know that, there are other projects, similar attempts to use Kubernetes as a base. Anaconda comes to mind. What they're doing, their distribution now it's containerized and can run on Kubernetes. How does this compare, or how does it complement KubeFlow?
Yeah, we've talked with the Anaconda folks a lot. We're really excited. Again, they're using Kubernetes native concepts, so ideally, we're able to figure out a way that they can use it, because Anaconda really provides, talking about that layering thing, talking about great data center operating system with something like Mesos, talking about your distributed container orchestration with Kubernetes, then you have KubeFlow on top of that, then you might even have a layer on top of that. Right now we ship with Jupyter, but you could also ship with Anaconda, you could ship with a number of different solutions, because that might be the layer data scientists would like to operate at. And so what we're really saying is it's up to the individual. If an individual understands how to go all the way up and down these stacks, great, more power to you. It's loosely coupled, it's stable, it's ready to go. If you really only understand that top layer, or Anaconda is your best interface, you can now, you can very easily use Anaconda on top of KubeFlow, on top of Kubernetes, on top of Mesos, and all the stacks understand how to play well together.
Well, listen, it's just, the show's just ending up, and they've actually opened the doors to the atrium here in the back. I think they need to get in their equipment to clear this place out. So thanks for staying here to the very end and joining us. It's been a really interesting conversation. I know we're going to be talking about this quite a bit. So thanks for joining us and helping us understand these topics.
Thanks so much for having us on.
Great, thanks.
Thank you.
The new stack thanks Mesosphere for sponsoring this podcast from Kubecon plus CloudNativeCon in Copenhagen, Denmark. Learn more about Mesosphere and how it unifies public and private clouds into a single pool of resources at mesosphere.com. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.